A rectangular concrete beam 100 mm wide by 250 mm deep spanning over 8 meter is pre-stressed by a parabolic cable with a pre-stressing force of 250 kN with zero eccentricity at the supports and 40 mm at the midspan. The beam supports a live load of 1.2 kN per meter. Determine the position of pressure line. So here, before going with the pressure line, all the basic calculations we need to do. So first let us plot the sketch. So in the given data, it is said that it is a rectangular cross section. So let us plot the rectangular cross section. B is 100, depth is 250, and let us also draw one longitudinal section, two dimensional one. Carries an UDL of 1.2 kilonewton per meter, and also most importantly it is a parabolic cable which is pre-stressed with a maximum eccentricity of 40 mm at the central span, and at the supports it is 0. At the supports means it is 0. So this is the parabolic cable. I'll just simply draw the cable. I'll just simply draw the cable, and this cable is having zero eccentricity. It is having zero eccentricity at the support. See, this is referred to as zero eccentricity, whereas here it is at the central span it is 40 mm. See, this is maximum value of 40 mm. At this support, the eccentricity is 0 because it is coinciding with the neutral axis, and this is referred to as p value. And this is how we need to plot the sketch. This is 40 mm eccentricity, and here it is 0 because at the ends it is coinciding with the neutral axis. And next, let us proceed. The rest of the calculation is very much similar to all the earlier problem what we had discussed. Calculate what is the area, B into D. Calculate what is moment of inertia, BD cube by 12. Calculate Z. Z, it can be calculated by two methods. One is with respect to the direct expression BD square by 6. Second is I by Y. Find out what is the dead load, live load, compute what is the total load. So after all those things, it is necessary to find out the bending moment at different span according to the given problem. So here also we are calculating at quarter span as well as mid span. So here we know that for a simply supported beam, bending moment at the support is always 0. It may be due to the presence of the hinge, roller or simple knife edge support. And let us calculate the same thing at the quarter span. Quarter means the total span here is 8. 8 divided by 2 is, 8 divided by 4 means 2. So we need to take section at 2 meter. And after that, calculated 7.2 is nothing but WL by 2, that is reaction value, into 2 minus 1.8 into 2 into 2 by 2, we get it as 10.8. And lastly we have the direct expression at the central span. Substitute it, we'll get the answer. And here one more important thing is that the given cable is parabolic cable. The given cable is parabolic, which always has the varying eccentricities. In the case of the straight cable, from the start to end, eccentricity remains constant, whereas in the case of the parabolic cable, since it follows the profile of a parabola like this, eccentricity is not constant with respect to the neutral axis or whatever it is. Eccentricity varies from point to point. Here the maximum value that is at the center is specified as 40, whereas at the support it is given as 0. But however, we are trying to find out at the quarter span here, which means at the 2 meter distance we need to know what is that eccentricity distance at 2 meter. This is referred to as y is equal to E, which is not known. That is y at quarter span you need to calculate it separately. So how do we calculate? So in order to compute this eccentricity distance, we are making use of the equation of parabola, which you have studied this long back right from your schooling. Okay, then now we shall make use of this expression, and h is nothing but the required central eccentricity, that is the maximum eccentricity. X is nothing but the value where it is required to be found out, where L is nothing but the span, the total span. So here we are trying to find it out at the quarter span. Quarter means 8 divided by 4. It is, you are trying to find it out at 2 meter. And next, carry out the calculations, we get after calculation y as 30 mm. After getting 30 mm value, let us proceed to the next. Okay, at the supports, we need to find out what are this test distribution here. We need to find out what are this test distribution here. So we need, let us take f superior expression and f inferior expression for the simply supported case. See, at the supports we know that eccentricity is 0 because cable is coinciding with the neutral axis, and also moment is equal to 0. You know that the bending moment at the support conditions is 0. So here this, all these expressions, it gets cancelled out because the m value is 0 at the supports, and after substituting we get the f superior as 10, f inferior as 10. And next case is that at quarter span, we have found out what is e value and what is bending moment. Okay, so substitute for everything, we'll get the answer, and similarly for f inferior. So after calculating we get both f's resultant stress at top and bottom fiber. And next, lastly, we are trying to calculate it at the mid span section. So for the mid span section, what is the eccentricity? It is 40 mm. What is the moment? 14.4. See here I have taken combinedly mg plus mq. We are taking it combinedly. Therefore here we have only 3 parts. So otherwise in the conventional method we separate it out and we calculate. In order to reduce the time, we can go with the combined mg, that is dead load plus live load combinations. You can make it out, and here find out what is f superior and find out what is f inferior. Okay, next, and here let us plot the stress block, that is stress distribution profile. Let us plot here. So we know that the pre-stress due to the direct stress due to the pre-stress, that is the stress block, is always compressive in nature. Therefore here the stress block which has been obtained as positive, that is the pre-stress due to the direct stress. And second case, draw a vertical line. We have got f superior as 13.17, f inferior as some value what we have received here from the expression, and connect it both. But we need to find out what is the center. The center of the rectangle, it is b by 2. Therefore I have directly shown here it as 125 mm. But this stress profile has gained the trapezoidal shape. So in such cases we need to apply the centroid expression. The centroid expression for the trapezoidal section can be taken as x is equal to a plus b, a plus 2b divided by a plus b multiplied by L by 3. And we can calculate here is a value is nothing but the 6.83, which has been calculated. And from these two expression, a is can be regarded as smallest value, b can be regarded as the biggest value. So a is 6.83 plus 2 into 13.7 divided by a plus b multiplied by L is nothing but the 250 divided by 3, and we get the value as 138.21. And lastly, we have to calculate even for the mid span condition. For the mid span condition, again the stress plot, let us draw one vertical line. Let us see here. Let us draw the vertical line. See here, f superior, it is positive, so therefore to the right I am plotting. F inferior is also positive, therefore to the right of the section I am plotting. And let me connect it both. Again, the stress distribution plot for at the mid span we are getting again as trapezoidal section. We need to find out the resultant. that is centroid. Okay, from this I'm trying to find out what is the distance. In order to find out the distance, we need to again apply the same formula. X is equal to a plus 2b by a plus b into L by 3. After substituting, we get the value as x is equal to 142.63 mm. After plotting the stress distribution, it is necessary for us to plot the pressure line. So pressure line, see, the procedure to calculate the pressure line for parabolic cable is different, and the procedure to calculate the obtain the pressure line for the straight cable is different. And here we are making use of all the centroid expressions, and we are trying to locate the resultant force. So here, as usual, I have drawn one longitudinal section. The given cable profile is parabolic in nature. So this is the parabolic. So with reference to, by taking with reference to the parabolic at a quarter span, we have got the values 138. So let us measure it from both the sides. At the central span, we got the values 148 to here, and same thing. And finally, let us connect this with the dotted line. This is nothing but the pressure line. The procedure has to be remained carefully, because it definitely varies for the straight cable, it varies for the parabolic cable also.